Bismillahirrahmanirrahim. Assalamu alaikum warahmatullahi wabarakatuh. In today's lesson, we will talk about two tests, which are Tollen's test and Seliwanoff's test. Okay, they are both of them are detecting of some carbohydrates, as we will see. We will start with Tollen test. It's a chemical test used to differentiate reducing sugars from non-reducing sugars and to identify the aldose sugars than ketose sugars. This test is also called the silver mirror test because the basis of the test, of the positive result of the test, is with the appearance of silver mirror at the end of the test. The result will be positive if the silver mirror present. So from this test is called the silver mirror test. The objectives of Tollen's test. Firstly, to distinguish reducing sugars from non-reducing sugars, and the basic thing is to detect the presence of aldehyde containing carbohydrates and differentiate them from ketone containing carbohydrates. So we will detect for aldehyde containing carbohydrates to test if the given samples containing aldehyde or aldose or ketose, because the Tollen's reagent reacts with the aldoses. So the positive result will be if the given sample containing aldoses, so the silver mirror will appearance at the end of the test. But if the given sample, or if the test sample containing ketoses, so the result will be negative. Okay, what's the principle of Tollen's test? The Tollen's reagent is the alkaline solution of silver nitrate, AgNO3. It is silver nitrate, which mixed with liquid ammonia, which results in the formation of a complex. This aqua complex, or this aqua solution of silver nitrate, forms a silver aqua complex. This silver aqua complex is oxidized by the action of hydroxide ions to form silver oxides. The silver oxides will result in a formation of brown precipitate at the base of the test tube. During you preparing the Tollen's test, you will observe this brown precipitate at the base of the test tube. This brown precipitate comes from the silver oxide. Then this silver oxide dissolved by aqueous ammonia, resulting in the formation of diamine silver hydroxide complex. This complex, which is diamine silver hydroxide, this is the primer component of the Tollen's reagent, and it's a strong oxidizing agent. With this complex, or through this complex, the aldehyde group at the aldose sugars will oxidize to give a carboxylic acid. So this is the complex, or the complex of the diamine silver hydroxide will oxidize the aldehyde group present in some sugars, which is aldose sugars like glucose. As you know, the aldose sugars are sugar containing aldehyde group, and ketose sugar, they're sugars containing ketone group. So this reagent, or this complex, Tollen's complex, oxidizes the aldehyde group present in the aldoses to form a carboxylic acid. At the same time, when this aldehyde group oxidized, at the same time the silver ions present in the reagent will reduce to metallic silver, and this metallic silver results in the formation of a mirror on the bottom and sides of the test tube, and this is the positive result for Tollen's test. The formation of a silver mirror as a result of oxidizing of aldehyde group present in the aldose sugars, and at the same time there is the reducting of silver ions into metallic silver, then the formation of the silver mirror at the bottom and sides of the test tube. However, an alpha hydroxyketone can give a positive Tollen's test, as the Tollen's reagent oxidizes the alpha hydroxyketone into an aldehyde, because this Tollen's reagent has a strong oxidizing agent, which is the diamine silver hydroxide. It's a strong oxidizing agent, so it can oxidize the alpha hydroxyketone into an aldehyde, and then it can also give a positive result in Tollen's test. So the positive result can be given by aldoses sugars and also by alpha hydroxyketone components, alpha hydroxyketone. So this is the reaction of Tollen's test after we preparing the Tollen's reagent. This primary component of Tollen's reagent, which is the strong oxidized, called diamine silver hydroxide. When we add the aldehyde, or when we add the sugar sample containing aldehyde group, and this is the aldehyde group, as you know, this strong reagent will oxidize the aldehyde group into carboxylic acid. At the same time, the silver present in the reagent will reduce to metallic silver. The reduction of this metallic silver will result as the formation of mirror or silver mirror on the bottom in the sides of the test tube. So the requirements of this test, we will need to prepare the reagent because it needs to freshly prepare Tollen's reagent. Prepare it by add 50 ml of 0.1 mole of silver nitrate to a beaker. Add 50 ml of 1.1 mole of silver nitrate to a beaker, and to this beaker add 25 ml of 0.8 ml of sodium or potassium hydroxide, and now add sufficient volume of aqueous ammonia in order to dissolve the brown precipitate. The brown precipitate comes from oxidizing of the silver to form a silver oxide. It forms a brown precipitate at the end of the test tube. Now the reagent is ready. We know we need to test sample as glucose, sucrose, fructose to test them if they're aldoses or ketosis. And materials required are test tube stand, and pipette. And the equipment is water bath because the reaction needs some heating for some time, like 1 minute at the water bath. The procedure of Tollen's test. Take 2 clean and dry test tubes. Okay, and add 1 ml of the test sample in 1 test tube. So we will take 1 test tube to add 1 ml of the sample. You will test it and mark it as a sample of, or mark it as you want. And in another tube take 1 ml of distilled water without any sample, just you will add the distilled water and mark it as a blank. And then add 2 ml of Tollen's reagent which you prepared or which you already prepared before. You'll take 2 ml of the Tollen's reagent and add it to that both of 2 test tubes. Keep both of the test tubes in a water bath for 1 minute and observe the formation of color and note it down. This is the result and interpretation of test tubes of Tollen's test. So as you see, the silver mirror appearance at the bottom and the sides of test tube. So that's mean this is a positive test, and that's mean this in this test tube or in this sample the aldehydes present. So this sugar is aldose sugar. So the color can be dark gray, precipitate, or silver mirror. Okay, can be dark gray or silver mirror. Both are a positive result for Tollen's test. If it's without color like this one, or if there is no gray color or mirror appearance, that means it is a negative result and there is no aldehydes at this sample, so the aldehydes absent. So this one is ketosis sugar. The formation of a dark gray precipitate or silver mirror on the bottom and the sides of the test tube indicates a positive result, which means that the given sample contains a reducing sugar aldoses. The absence of such precipitate indicates a negative result, which means that the test sample does not have reducing sugars, aldoses, and even alpha hydroxyketosis. Because I said the alpha hydroxyketosis can also give a positive result, but if it's a negative result, that means the sample does not have aldoses or alpha hydroxyketosis. So what the uses of Tollen's test? Is routinely performed in chemical laboratories for the qualitative organic analysis, which distinguishes aldehydes from ketones. It's at the qualitative organic analysis which distinguishes aldehydes from ketones. This test also used for the differentiation of reducing sugars from non-reducing sugars. Because if the result is negative, that means the sample doesn't have reducing sugars. The limitation of Tollen's test. Some carbohydrates that do not have an aldehyde group might give a positive result. Why? Because the Tollen's reagent is a strong oxidized agent, and the alkaline medium and the Tollen's reagent can do isomerization of such sugars, and then they can give a positive result in the Tollen's test. Although they have no aldehyde group, but after isomerization of these sugars under the alkaline conditions, they can give a positive result of Tollen's test. I hope it's understood, or I hope you understand this well. If you have any question, you can ask me. This is about the Tollen's test, and now we will shift to another test for today, which is Seliwanoff's test. Seliwanoff's test. Okay, Seliwanoff's test is a biochemical test which is used to identify the presence of ketosis and aldoses. This test is based on the principle that on heating or on treatment with a concentrated acid, the ketosis dehydrated more rapidly than aldoses. I will say it again. The basic or the principle of this Seliwanoff test, based on the heating or on treatment with a concentrated acid, the ketosis dehydrate more rapidly than aldoses. That means the ketosis will give a positive result in this test if they are present in the sample, because they dehydrate more rapidly than aldoses. So we will detect for the ketosis at the given sample of carbohydrates. This test is a timed color reaction specific to ketohexosis. What the mean of time color? That means at the short time, it's like 1 minute or 30 seconds, not more. If the sample had a ketosis, the positive result will appears as the formation of a cherry red color at the test tube. So at the short time, which is about 30 seconds, not more, the positive result will appear. But if it takes a prolonged time, the positive result also can appear, but you will say it's a negative because it's more than 30 seconds. So at this test, it depends on the time, because aldosis also can dehydrated by heating and treatment with a concentrated acid, but the ketosis more rapidly, dehydrated more rapidly than aldosis. So aldosis takes more time to give a positive result. Ketosis do not need too long time. So this test depending on the time of the formation of the color for the positive test. The principle of Seliwanoff's test. The reagent of this test consists of resorcinol and concentrated hydrochloric acid. These two components, resorcinol and concentrated hydrochloric acid, are the basic components of the Seliwanoff reagent. The acid hydrolysis of polysaccharides and oligosaccharides yield simpler sugars. As you know, the polysaccharides and oligosaccharides consist of several molecules of monosaccharides. So the concentrated hydrochloric acid will hydrolyze them to yield a simpler sugars. Okay, these sugars, simpler sugars, can be ketosis or aldosis. So ketoses are more rapidly dehydrated than aldosis. Ketoses undergo dehydration in the presence of concentrated acid to yield 5-hydroxymethyl furfural. This component will given by the dehydration of ketosis in the presence of concentrated hydrochloric acid. So the dehydration or the dehydrated ketose then react with two equivalents of resorcinol in the series of condensation reactions to produce a complex, not a precipitate, to produce a complex termed xanthinoid with deep cherry red color. So this is the positive result for the test with the formation of deep cherry red color. I will repeat this paragraph again. Okay, the ketosis undergo dehydration in the presence of concentrated hydrochloric acid to yield 5-hydroxymethyl-furfural. Okay, so this 5-hydroxymethyl-furfural, or we can say the dehydrated ketose, reacts with two equivalents of resorcinol. Okay, and then this reaction will happen in a series of condensation reactions to produce a complex, not precipitate, it's a complex. This complex termed xanthinoid. Okay, the xanthinoid results as a formation of deep cherry red color. Aldoses may react slightly to produce a faint pink to cherry red color if the test is prolonged. That means if the test takes or after more seconds or more minutes, the aldoses also can give a positive result by formation of faint pink to cherry red color if the test is prolonged. But if this happens, you can say this, or you can make sure it's aldoses, it's not ketosis, because ketosis do not or does not take prolonged time, because they rapidly dehydrated than more than aldoses. So the aldoses react slightly to produce the faint pink or to cherry red color if the test is prolonged. The product and reaction time, of the oxidation reaction helps to distinguish between carbohydrates. As I said, the ketoses more rapidly and they give a deep cherry red color, but aldoses react slightly and need a prolonged time, and they give a faint pink to cherry red, not deep cherry, just cherry red color. So through the final product and the reaction time, through these two factors, we can distinguish between the ketosis and aldoses. Other carbohydrates like sucrose and inulin also give a positive result for this test, as these are hydrolyzed by acid to give fructose. So because it's a concentrated acid, it can hydrolyze inulin and sucrose also to give a fructose, and fructose is a ketosis, and then this sucrose and inulin can give a positive result also. Okay, what are the requirements of the Seliwanoff test? We need to prepare the reagent, which consists of resorcinol and concentrated hydrochloric acid. So to prepare the Seliwanoff reagent, we will dissolve 50 mg of resorcinol in 33 mg of concentrated hydrochloric acid and make it up by distilled water to 100 ml. And then we need test samples to test them. distinguish between aldosis and ketosis, and we need distilled water. Materials required: test tube stand, and pipettes. Equipments: a water bath because the reaction needs heating. Procedure of Seliwanoff's test: take 2 clean and dry test tubes and add 1 ml of the test sample in one test tube and mark it as a test sample or whatever the sample was, glucose, fructose, anyone. And in another another test tube, add 1 ml of distilled water and mark it as a blank. Then add 2 ml of Seliwanoff's reagent to both the test tubes. Keep both test tubes in a water bath for 1 minute. So at this time you will observe the formation of color at the test tubes. Try to observe the formation of color and note it down. The result and interpretation of Seliwanoff's test. This is the formation of the cherry red color, which should be deep cherry red color when the ketosis present, and if the sample was aldosis, this color will appear but not deep color, will appear red to faint pink after prolonged time if the sample was aldosis. But if it's ketosis, that deep cherry red color will appear. So this is a positive Seliwanoff test. And the negative result, or in the blank test tube, we will find there is no complex or cherry red color complex formed at the test tube. So the ketosis are absent. The formation of the cherry red colored complex indicates a positive result, which means that the given sample contains ketosis. The absence of such color or the appearance of the color after prolonged period of time indicates a negative result, which means that the test sample does not have ketosis, but it can have aldosis. Okay, the uses of Seliwanoff's test. Seliwanoff's color reaction is used in the method for the colorimetric determination of fructose in fermentation media. As you know, fructose is a ketosis. So they use this color reaction of Seliwanoff as a method for the colorimetric determination of a fructose in a formation media. A modified version of this test can be used for the determination of the concentration of ketosis in a given sample. That means the concentration of ketosis in a given sample can give a vary or different concentration of color. So they can determine the concentration of ketosis in a given sample in the modified version of Seliwanoff's test. The limitation of Seliwanoff's test. the high concentration of glucose, which is aldoses, or other sugar, may interfere by producing similar colored compounds with Seliwanoff's reagent, and this will give a strong or a wrong result. You may think that it's a positive result in the sample containing ketosis, but that's not true, because the interfere of a high concentration of glucose or other sugar in the sample producing a similar color compound. And also prolonged boiling can transform glucose to fructose by the catalytic action of acid and form cherry red complex, and also this given a false positive result. Because of that, the boiling time is just for 1 minute, not more, to avoid the false positive result. This test is a generalized test and does not distinguish between specific ketoses. It just indicates for the present or the absence of ketosis in the given sample, but not or does not distinguish between the specific ketoses. And a separate test is required for the particular ketose sugar identification. If you need to identify a particular ketose sugar, you need a separate test to identify it. But the Seliwanoff's test is a generalized test, just to identify the ketosis if it's absent or present in the given sample. Okay, but not for distinguish between specific ketoses. Okay, I will repeat that more and more. If there are any question, you can ask me anytime, and I hope it's clear. All it's clear, and see you later.